Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using integrating factors. So let's get going. Problem: solve x cube y cube into 2y dx plus x dy minus of 5y dx plus 7x dy. Given differential equation: x cube y cube into 2y dx plus x dy minus of 5y dx plus 7x dy equal to 0. Consider as equation 1, which is of, okay, fine. Now we can write this equation as x cube y cube into 2y dx plus x dy minus, here just take this minus inside the brackets. You'll get minus 5 y dx plus minus 7 x dy, okay? And also here we have 1, right? We just have nothing. We can consider it as 1. And we can write this 1 in terms of x to the power and y to the power. Okay, since x power 0 is 1 and y power 0 is 1, so we can write 1 as some 1 into 1. We'll replace 1 by x power 0 and another 1 by y power 0, so that we can write this 1 as x power 0 into y power 0 for our convenience. Okay, I'll write one more step. Okay, so I'm going to write one more step. You can just skip this too. Okay, I'll replace this 1 by x power 0 into y power 0 into minus 5y dx plus minus 7x dy equal to 0. I'll consider some equation 2, which is of x power a y power b into mydx plus nx dy plus x power c y power d into pydx plus qxdy equal to 0 form. Okay, since the given equation is of this form, so here x power alpha y power beta will be the integrating factor. Okay, see here, by looking at this we can say that it is non-exact and we need an integrating factor to solve this problem. Okay, because this is of this form. Okay, by looking at this we can say that this is of a power x power a y power b into some two terms and this form. So by looking at the equation itself we can say this is of this form, and here x power alpha y power beta is the integrating factor. Okay, and it is non-exact. Okay, if you are not sure that it is exact or not exact, you just write the given differential equation in mdx plus ndy equal to 0 form, and then check whether the given equation is exact or not. We can check this later after finding the solution to this problem. Okay, fine. Since the given differential equation is of this form, so x power alpha y power beta will be the integrating factor, and here we need to find alpha and beta. Let's see that. Now by comparing these two, let's find the values of unknowns, where a equal to 3, b equal to 3, c equal to 0, d equal to 0, and m equal to 2, n equal to 1, p equal to -5, q equal to -7. Let x power alpha into y power beta be the integrating factor. Okay, now multiplying one by integrating factor x power alpha y power beta. This is the equation 1. Okay, fine. Now let's multiply the given equation by integrating factor. We all know that the non-exact equation can be reduced to an exact equation by multiplying it with an integrating factor, right? Fine. So here the equation is x cube y cube into 2y dx plus x dy minus 5y dx plus 7x dy equal to 0. This gives us x power alpha y power beta into 2 x cube y cube into y power 4 into dx plus x cube into x power 4 y cube dy minus of same thing 5y dx plus 7x dy equal to 0, right? Now multiply these two terms by this x power alpha and y power beta. This gives us 2 x power alpha into x cube y power beta into y power 4 into dx plus x power alpha x power 4 y power beta into y cube dy minus 5 x power alpha y power beta into y into dx minus 7 x power alpha into x y power beta into dy equal to 0, right? If the bases are equal, we can add the powers, we know that. So let's add the powers. We'll get 2 x power alpha plus 3 y power beta plus 4, it's beta, okay, dx plus x power alpha plus 4 y power beta plus 3 into dy minus 5 x power alpha y power beta plus 1 into dx minus 7 x power alpha plus 1 y power beta into dy equal to 0. Now let's write this in mdx plus ndy equal to 0 form. Now take dx common from the first term and the third term and dy common from the third, second term and the last term. We'll get 2x power alpha plus 3 y power beta plus 4 minus 5x power alpha y power beta plus 1 into dx plus x power alpha plus 4 y power beta plus 3 minus 7x power alpha plus 1 y power beta into dy equal to 0, right? This is of mdx plus ndy equal to 0 form. For m equal to 2x power alpha plus 3 y power beta plus 4 minus 5x power alpha y power beta plus 1, and for n equal to x power alpha plus 4 y power beta plus 3 minus 7x power alpha plus 1 y power beta, right? Consider this equation as some asterisk. Okay, so equation asterisk is exact if partial derivative of m with respect to y equal to partial derivative of n with respect to x. For m equal to 2x power alpha plus 3 y power beta plus 4 minus 5x power alpha y power beta plus 1, and for n equal to x power alpha plus 4 y power beta plus 3 minus 7x power alpha plus 1 y power beta. Okay, then partial derivative of m, that is 2x power alpha plus 3 y power beta plus 4 minus 5x power alpha y power beta plus 1 equal to partial derivative of n with respect to x, n for n equal to x power alpha plus 4 y power beta plus 3 minus 7x power alpha plus 1 y power beta. So you can name this m as m1 and n as n1. Okay, but for my convenience I am writing m and n. Okay, well, this gives us, here in LHS we are partially differentiating with respect to y. We are differentiating the terms with respect to y, right? So x will be treated as constant. In the first term 2x power alpha plus 3 is constant, and in the second term 5x power alpha is treated as constant, right? And in the RHS part we need to partially differentiate the two terms with respect to x. So y will be treated as constant in the first term, y power beta plus 3 is treated as constant. In the second term 7 y power beta will be treated as constant. Now we'll write this as 2x power alpha plus 3, which is a constant, into partial derivative of y power beta plus 4 minus constant 5x power alpha into partial derivative of y power beta plus 1 equal to constant y power beta plus 3 into partial derivative of x power alpha plus 4 minus constant 7 y power beta into partial derivative of x power alpha plus 1. This gives us 2x power alpha plus 3 into partial derivative of y power beta plus 4 with respect to y is beta plus 4 into y power beta plus 4 minus 1 minus 5x power alpha into partial derivative of y power beta plus 1 with respect to y is beta plus 1 into y power beta plus 1 minus 1 equal to y power beta plus 3 into partial derivative of x power alpha plus 4 with respect to x is alpha plus 4 into x power alpha plus 4 minus 1 minus 7 y power beta into partial derivative of x power alpha plus 1 with respect to x is alpha plus 1 into x power alpha plus 1 minus 1, right? Minus 1 plus 1 gets cancelled, and this gives us 2x power alpha plus 3 into beta plus 4 into y power beta plus 4 minus 1 gives plus 3 minus 5x power alpha into beta plus 1 into y power beta equal to y power beta plus 3 into alpha plus 4 into x power alpha plus 4 minus 1 gives plus 3 minus 7 y power beta into alpha plus 1 into x power alpha. This gives us 2 beta plus 4 into x power alpha plus 3 y power beta plus 3 minus 5 beta plus 1 into x power alpha y power beta equal to alpha plus 4 into x power alpha plus 3 y power beta plus 3 minus 7 into alpha plus 1 into x power alpha y power beta. Okay, now equating the like terms, equating the coefficients of like terms. See, by equating the coefficients of like terms, we'll get some equations, and by solving that equations, we'll get the values of alpha and beta here. Okay, we'll begin with x power alpha plus 3 y power beta plus 3. So we'll equate the coefficients of x power alpha plus 3 y power beta plus 3 firstly. Then you'll get 2 times beta plus 4 equal to alpha plus 4, which gives us 2 beta plus 8 equal to alpha plus 4, or we can write this as alpha plus 4 equal to 2 beta plus 8. Now bring this 2 beta to LHS, take this 4 to RHS, you'll get alpha minus 2 beta equal to 8 minus 4, which gives us alpha minus 2 beta equal to 4. Okay, consider it as equation number A. Now equating the coefficient of x power alpha y power beta, you'll get 5 minus 5 into beta plus 1 equal to minus 7 into alpha plus 1, or 7 times, minus 7 times alpha plus 1 we can say. You'll get 5 times beta plus 1 equal to 7 times alpha plus 1. You can write this as 5 beta plus 5 equal to 7 alpha plus 7, or we can write this as 7 alpha plus 7 equal to 5 beta plus 5. Now bring this 5 beta to LHS, take this 7 to RHS, then you'll get 7 alpha minus 5 beta equal to 5 minus 7, which gives us 7 alpha minus 5 beta equal to minus 2. Consider as equation B. Now we are having two equations, alpha minus 2 beta equal to 4 and 7 alpha minus 5 beta equal to minus 2. Now by solving these two, we'll get the values of alpha and beta. We have equation A and B, alpha minus 2 beta equal to 4 and 7 alpha minus 5 beta equal to minus 2. Now by solving these equations, we need to find A and B, right? So I'll try to eliminate alpha from these two. Okay, firstly I'll try to cancel the terms involving alpha from these two equations. So for that we need a 7 here. So what we'll do is we'll just multiply equation A by 7. Then you'll get 7 alpha minus 7 2s are 14 beta equal to 7 4s are 28, right? Fine. Now write the B as it is and solve this equation. Plus 7 alpha minus 7 alpha gets cancelled. Minus 14 beta plus 5 beta gives minus 9 beta equal to plus 28 plus 2 gives plus 30. From this we'll get beta equal to minus 30 by 9, right? Now substitute beta value in any of these two equations. So I'll consider the first one, alpha equal to, we have equation A, alpha minus 2 beta equal to 4. I'll write this as alpha equal to 4 plus 2 beta Now I'll substitute the value of beta, since beta equal to minus 30 by 9. This gives us 2 into minus 30 by 9. Okay. See, here itself you can get minus 10 by 3. Let's substitute minus 10 by 3. Okay, this gives us 12. Plus into minus minus, 2 times are 20 by 3. 12 minus 20 gives minus 8 by 3. Therefore, alpha equal to minus 8 by 3 and beta equal to minus 10 by 3. So you can also substitute beta value in equation B to find alpha. You'll get the same answer. Okay, fine. Since alpha equal to minus 8 by 3 and beta equal to minus 10 by 3, then the integrating factor becomes x power alpha y power beta equal to x power alpha minus 8 by 3 y power beta minus 10 by 3. Now multiplying x power minus a by 3 8 by 3 minus into y power minus 10 by 3 to 1. Since it is a integrating factor, so by multiplying it to 1, the equation reduces to an exact equation. Okay. This gives us x power minus 8 by 3 y power minus 10 by 3 into 2 into x cube y cube into y gives y power 4 into dx. Since the bases are equal, powers can be added, plus x cube into x power 4 y cube into dy minus of 5ydx plus 7xdy equal to 0. Now multiply each term with x power minus 8, that is the integrating factor. Then this gives us x power minus 8 by 3 y power minus 10 by 3 into 2x cube y power 4 dx plus x power 4 y cube into dy minus x power minus 8 by 3 y power minus 10 by 3 into 5y dx plus 7x dy equal to 0. This gives us 2 x power minus 8 by 3 into x cube y power minus 10 by 3 y power 4 into dx plus x power minus 8 by 3 into x power 4 y power minus 10 by 3 into y cube dy minus 5 into x power minus 8 by 3 y power minus 10 by 3 into y dx minus 7 into x power minus 8 by 3 into x y power minus 10 by 3 into y into dy equal to 0, right? Now add the powers if the bases are equal. You'll get 2 into x power minus 8 by 3 plus 3 y power minus 10 by 3 plus 4 into dx plus x power minus 8 by 3 plus 4 y power minus 10 by 3 plus 3 into dy minus 5 into x power minus 8 by 3 y power minus 10 by 3 plus 1 into dx minus 7 into x power minus 8 by 3 plus 1 y power minus 10 by 3 into dy equal to 0. So we are having minus 8 by 3 plus 3 minus 10 by 3 plus 4 minus 8 by 3 plus 4 minus 10 by 3 plus 3 and minus 10 by 3 plus 1 minus 8 by 3 plus 1. Let's simplify all this. We'll get minus 8 plus 9 by 3, which gives us 1 by 3, minus 10 plus 12 by 3, which gives 2 by 3, minus 8 plus 12 by 3, which gives us 4 by 3, minus 10 plus 9 by 3 gives minus 1 by 3, minus 10 plus 3 by 3 gives minus 7 by 3, and here we'll get minus 8 plus 3 by 3, which gives us minus 5 by 3. Okay, then this becomes 2 into x power minus 8 by 3 plus 3 by 3, which is 1 by 3, into y power minus 10 by 3 plus 4, 2 by 3, into dx plus x power minus 8 by 3 plus 4 is x power 4 by 3, y power minus 10 by 3 plus 3 is minus 1 by 3, into dy minus 5 into x power minus 8 by 3, y power minus 10 by 3 plus 1 gives minus 7 by 3, minus into dx, right, minus 7 x power minus 8 by 3 plus 1 is minus 5 by 3, into y power minus 10 by 3, into dy equal to 0. Let's now take terms, write the terms involving dx firstly and then go for the terms involving dy. You will get x power 1 by 3 y power 2 by 3 into dx minus 5x power minus 8 by 3 y power minus 7 by 3 into dx plus terms involving dy is x power 4 by 3 y power minus 1 by 3 into dy minus 7 x power minus 5 by 3 y power minus 10 by 3 into dy equal to 0. This gives us, now take dx common from the first two terms, you'll get 2x power 1 by 3 y power 2 by 3 minus 5x power minus 8 by 3 y power minus 7 by 3 into dx plus take dy common from the next two terms, you'll get x power 4 by 3 y power minus 1 by 3 minus x power 7 x power minus 5 by 3 y power minus 10 by 3 into dy equal to 0, which is of mdx plus ndy equal to 0 form, or you can name it as m2dx plus n2dy equal to 0 form. If you have considered the equation asterisk as m1dx plus n1dy, you can consider it as m2dx plus n2dy equal to 0, right? Which is of mdx plus ndy equal to 0 form. For m equal to 2x power 1 by 3 y power 2 by 3 minus 5x power minus 8 by 3 y power minus 7 by 3, and for n equal to x power 4 by 3 y power minus 1 by 3 minus 7 into x power minus 5 by 3 y power minus 10 by 3. Let's consider this equation as equation 3. Now, this equation 3 is exact if the partial derivative of m with respect to y equal to partial derivative of n with respect to x. For m equal to this one and for n equal to this one, right? So let's check whether the partial derivatives of m with respect to y, the two partial derivatives are equal or not. I'll begin with the partial derivative of m with respect to y. Here we are finding partial derivative of terms with respect to y. So we'll treat x as constant. In the first term 2x power 1 by 3 is constant. In the second term minus 5 x power minus 8 by 3 is treated as constant. So we can write it as 2x power 1 by 3 into partial derivative of y power 2 by 3 with respect to y minus constant 5x power minus 8 by 3 into partial derivative of y power minus 7 by 3 with respect to y. This gives us 2x power 1 by 3 into partial derivative of y power 2 by 3 with respect to y is 2 by 3 into y power 2 by 3 minus 1 minus 5x power minus 8 by 3 into partial derivative of minus 7 by 3 into y power minus 7 by 3 minus 1. Okay. Let's simplify 2 by 3 minus 1, which gives us minus 1 by 3, and simplify minus 7 by 3 minus 1, which gives us minus 7 minus 3 by 3, which is minus 10 by 3. Okay, then this becomes 2 into 2 by 3 gives 4 by 3 into x power 1 by 3. Y power 2 by 3 minus 1 is minus 1 by 3 minus 5 into minus 7 gives plus 5 7s are 35 by 3 into x power minus 8 by 3 y power minus 7 by 3 minus 1 gives minus 10 by 3. Okay. So we got the value for partial derivative of m with respect to y. Now coming to the partial derivative of n with respect to x. Here we are finding partial derivative with respect to x. So y will be treated as constant in the first term. Y power minus 1 by 3 is constant. In the second term minus 7 into y power minus 10 by 3 is considered as constant. So we can write this as y power minus 1 by 3 into partial derivative of x power 4 by 3 minus 7 into y power minus 10 by 3 into partial derivative of x power minus 5 by 3. This gives us y power minus 1 by 3 into partial derivative of x power 4 by 3 with respect to x is 4 by 3 into x power 4 by 3 minus 1 minus 7 into y power minus 10 by 3 into partial derivative of x power minus 5 by 3 with respect to x is minus 5 by 3 into x power minus 5 by 3 minus 1. Right? Let's simplify 4 by 3 minus 1 and minus 5 by 3 minus 1. 4 by 3 minus 1 gives 4 minus 3 by 3, which gives us 1 by 3. And minus 5 by 3 minus 1 gives minus 5 minus 1 by 3, which is, minus 5 minus 3 by 3, which gives us minus 8 by 3. This becomes 4 by 3 into x to the power 4 by 3 minus 1 is 1 by 3 into y power minus 1 by 3 minus, okay, minus into minus plus, 7 5 is a 35, 35 by 3 into x to the power minus 5 by 3 minus 1 is minus 8 by 3 into y power minus 10 by 3. Okay, so by observing this two, we can say that therefore the partial derivative of m with respect to y equal to partial derivative of n with respect to x. It shows that the reduced equation, that is equation 3, is exact. Since equation 3 is exact, so we can use the general solution formula of an exact equation to find the general solution to equation 3, which will be the required solution to equation 1, that is the given differential equation. So now coming to the general solution, we know that the general solution to an exact equation which is of the form mdx plus ndy equal to 0 is given by integral mdx treating y as constant plus integral terms of n free from x into dy equal to c. Okay, now let's find each integral separately for our convenience. Okay, I'll begin with the first integral treating y as constant. We have m 2 into x power 1 by 3 y power 2 by 3, this is our m. Okay, minus 5x power minus 8 by 3 y power minus 7 by 3 into dx. So here we have to treat y as constant, right? In the first term 2 into y power 2 by 3 is constant, and in the second term minus y power minus 7 by 3 is treated as constant. Now we can write this as 2 y power 2 by 3 into integral x power 1 by 3 dx minus 5 y power minus 7 by 3 into integral it's x power minus 8 by 3 into dx. Okay, this gives us 2 y power 2 by 3 into integral x power 1 by 3 dx is x power 1 by 3 plus 1 by 1 by 3 plus 1. I'll write it again. Okay, this becomes 2 y power 2 by 3 into integral x power 1 by 3 dx is x power 1 by 3 plus 1 by 1 by 3 plus 1 minus 5 y power minus 7 by 3 into integral x power minus 8 by 3 is x power minus 8 by 3 plus 1 by minus 8 by 3 plus 1. Let's simplify 1 by 3 plus 1 and minus 8 by 3 plus 1. This gives us 1 plus 3 by 3, that is 4 by 3. And minus 8 by 3 plus 1 gives minus 8 plus 3 by 3, which gives us minus 5 by 3. This gives us, coming to first integral, we'll get 2 y power 2 by 3 into x power 4 by 3 by 4 by 3 minus 5 into y power minus 7 by 3 into x power minus 8 by 3 plus 1 is minus 5 by 3 by minus 5 by 3. So we can write this as 2 into reciprocal of 4 by 3 is 3 by 4 into x power 4 by 3 y power 2 by 3 minus 5 into reciprocal of 1 by minus 5 by 3 is minus 3 by 5 into x power minus 5 by 3 y power minus 7 by 3. Okay, so here this 5 gets cancelled. This gives us, it's 2, okay, 2 2s are 4, so you will get from 1 3 by 2 into x power 4 by 3 y power 2 by 3 minus into minus plus 3 into x to the power minus 5 by 3 y to the power minus 7 by 3. So now we can take 3 by 2 common from these two terms, since second term doesn't has 1 by 2. So we'll multiply and divide 2 to this term. Now let's take 3 by 2 common from these two terms. We'll get 3 by 2 into x power 4 by 3 y power 2 by 3 plus, if you take 3 by 2 common, you'll get 2x power minus 5 by 3 y power minus 7 by 3. This is the result obtained from the first integral. Okay, now coming to the second integral. See, or we can take x power minus 5 by 3 y power minus 7 by 3 common from these two terms. But in the first term you don't have any x power minus 5 by 3 y power minus 7 by 3. So what we'll do is, we'll just add and subtract minus 5 by 3. See, suppose we have 1, it can be written as x to the power 0, right? So you can just replace this 0 by minus 5 by 3 plus 5 by 3, right? So you can just write, suppose assume that you have 1 here, and you can replace this 1 by 1 into 1, replace 1 by x power minus 5 by 3 plus 5 by 3, and another 1 by y power 0, and replace this 0. I mean, you can write this 0 as some minus, we need minus 7 by 3 plus 7 by 3. Okay, so now we'll replace this 1 as x to the power 0 into y to the power 0, or simply x to the power minus 5 by 3 plus 5 by 3 into y power minus 7 by 3 plus 7 by 3. Okay, since 1 equal to 1 into 1, x power 0 into y power 0, x power, the 0 can be written as, since we need x power minus 7 by 3, sorry, minus 5 by 3, so we'll write it as minus 5 by 3 plus 5 by 3, and y to the power, the 0 can be written as minus 7 by 3 plus 7 by 3, since you need y power minus 7 by 3. Okay, now I'll replace this 1 by x power minus 5 by 3 plus 5 by 3 y to the power minus 7 by 3 plus 7 by 3 into x power 4 by 3 y power 2 by 3 plus 2 x to the power minus 5 by 3 y to the power minus 7 by 3. Okay, see, this gives us x power 0, y power 0, and x power 0 into y power 0 is 1 into 1, which gives us 1. Okay, fine. Again, 1 into x power 4 by 3 y power 2 by 3 gives the same term. Now we'll write this as 3 by 2 into, split these two terms, x power minus 5 by 3 into x power 5 by 3 y power minus 7 by 3 into y power 7 by 3 x power 4 by 3 y power 2 by 3 plus 2x power minus 5 by 3 y power minus 7 by 3. Now take x power minus 5 by 3 and y power minus 7 by 3 common from these two terms. We'll get 3 by 2 into x power minus 5 by 3 y power minus 7 by 3 into x power 5 by 3 into x power 4 by 3 into y power 7 by 3 y power 2 by 3 plus 2. Okay. Here the bases are equal, so we'll add the powers. Then we can write this as 3 by 2 into x to the power minus 5 by 3 into y to the power minus 7 by 3 can be written as 1 by x power 5 by 3 y power 7 by 3. Since x power minus n can be written as 1 by x power n, likewise y power minus n can be written as 1 by y power n. Okay. Or you can just write it as x power minus 5 by 3 into y power minus 7 by 3 can be written as 1 by x power 5 by 3 into 1 by y power 7 by 3, which gives us 1 by x power 5 by 3 into y power 7 by 3. Okay. Into x power, add the powers, 5 by 3 plus 4 by 3 into y power 7 by 3 plus 2 by 3 plus 2. Now simplify 5 by 3 plus 4 by 3, which gives us 5 plus 4 by 3, 9 by 3 is 3, and 7 by 3 plus 2 by 3 gives 7 plus 2 by 3, which gives 9 by 3. From this you'll get 3. Okay. Then this gives us 3 by 2 into 1 by x power 5 by 3 y power 7 by 3 into x power 5 by 3 plus 9 by 3 is 3, y power 7 by 3 plus 2 by 3 is 3 plus 2. So this is the result obtained from the first integral. Now coming to the second integral. Second integral is integral of terms of n free from x into d1. Now observe n. This is our n, right? We don't have terms which are free from x. So integral of terms of n free from x is 0. So the result obtained from the second integral is 0. Now coming to the general solution. Therefore, the general solution to equation 3 is given by integral mdx treating y as constant plus integral terms of n free from x into dy equal to c, which gives us, so the result obtained from the first integral is 3 by 2 into 1 by x power 5 by 3 y power 7 by 3 into x cube y cube plus 2 plus result obtained from the second integral 0 equal to c, which gives us three by 2 into 1 by x power 5 by 3 y power 7 by 3 into x cube y cube plus 2 equal to c. Now take these two terms to RHS. This gives us 1 by x power 5 by 3 y power 7 by 3 into x cube y cube plus 2 equal to, I am taking this constant to RHS, so I will get 2c by 3. Let 2c by 3 equal to some c. Okay. Now we can write this as 1 by x power 5 by 3 y power 7 by 3 into x cube y cube plus 2 equal to c. Now take this term to RHS, then you'll get x cube y cube plus 2 equal to c into x power 5 by 3 y power 7 by 3, which is the required solution to the given differential equation. Therefore, x cube y cube plus 2 equal to c into x power 5 by 3 y power 7 by 3 is the required solution. Which completes the problem. Now let's see whether the given differential equation is exact or not. We can write the given differential equation as we can write the given differential equation as 2x cube y power 4 y cube into y is y power 4 into dx plus x cube into x power 4 y cube dy minus 5y dx minus 7x dy equal to 0. Now take dx common from these two terms, we'll get 2x cube y power 4 minus 5y into dx plus take what dy common from these two terms, we'll get x power 4 y cube minus 7x into dy equal to 0, which is of mdx plus ndy equal to 0 form for m equal to this one and from equal to the terms under brackets, right? So here we need to find partial derivative of m with respect to y and partial derivative of n with respect to x. If these two are equal, we can say that the given differential equation is exact or this equation is exact. Let's find partial derivatives of m and n. Partial derivative of m with respect to y is, here we are finding partial derivative of m with respect to y. So we'll treat x as constant. So you'll get 2x cube into partial derivative of y power 4 with respect to y is 4y cube minus 5 into partial derivative of y with respect to y is 1, which gives us 2 4s are 8 x cube y cube minus 5. Now let's find partial derivative of n with respect to x. Since we are finding partial derivative with respect to x, so we'll treat y as constant here. We'll get y cube into partial derivative of x power 4 with respect to x is 4x cube minus 7 into partial derivative of x with respect to x is 1, which gives us 4 x cube y cube minus 7. Right? By observing these two, we can say that the partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. Therefore, the given differential equation is not exact. Well, we have seen a differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.